And a few you can start by looking at that. You probably tried it earlier, but we are just going to do one problem today. We're going to look at Indiana Jones, then tomorrow you got your quiz, which I can unlock right after this problem, actually, is what I'll do. And then that'll take care of tomorrow's math class as well. It shouldn't be too long today. Hopefully you enjoyed field day yesterday. Whatever that entitled. I think I am set up. You can go ahead and give that a shot. I will be back. I'm going to go grab something to drink. But I'll leave that up. I'm just going to hide myself and Alright. So if you're just coming on, that's okay. You got a couple minutes before we start. Yeah, you have Miss Holden today at 2. I'm going to do one problem with you. And then I'm going to see if you have any further questions on this. Tomorrow you have your quiz, which I can unlock right after this if you want to spend more time doing that. So I won't live stream tomorrow. Today will not be hard. We got one problem. And I need to get out of this layer. That's what I need to do. That up there, and this is actually a cubed. It's just that my drawing program does not like exponents. So go ahead, give this one a shot if you didn't already. If you did already, check your answers as I do it. We're going to go through one problem, then tomorrow. So tomorrow you have a quiz, which is 6 problems. That's it. I will unlock it today after this. And then Wednesday we start our next chapter, which is 2 variable relationships. Not really that difficult, but something, actually it's probably one of my more favorite things to do. We'll get into linear equations and stuff, and we probably won't get much further than that this year, because we can get pretty in-depth with that. What is a pedestal? It's a pedestal. There's like your pedestal, and then you put something on top. In this case, it's like a skull or something. Make it more columny. You ever seen Indiana Jones? I thought this was a movie everybody's seen. Indiana Jones Raiders of the Lost Ark. He's going through the little cave at the beginning. There's an idol sitting on this little, well, it's a pedestal. He lifts it up, throws on the bag of sand, and runs off. And then triggers a bunch of boulders, or a giant boulder to follow him, I guess. Classic movie. It's the best Indiana Jones movie. Some people are going to like, no, Last Crusade's the best, but no, it's Raiders of the Lost Ark. Those people are wrong. Then Temple of Doom was kind of strange. That was a strange Indiana Jones one. It didn't fit the other ones. And then they made a 4th one, but we don't talk about it. Yeah, his friend betrayed. Yeah, see, Anna's seen it. It's a good movie. Classic Indiana Jones. Steven Spielberg. John Williams did the music score. Has all good movies. Because he's like the best at that. But anyways, let's get the problem done. We don't need a pedestal. Alright, in Leaders of the Lost Ark, Indiana Jones tries to remove the gold idol from a booby-trapped pedestal. He replaces the idol with a bag of sand. The idol has a mass of 2 kilograms. How many liters of sand must he place on the pedestal to keep the mass-sensitive booby trap from activating? And it says here, the density of sand is 3 grams per centimeter cubed. And there's some more information that you might not know that you might had to have gone and looked up. It does give you this, but let's pull it apart, because remember, this here is your conversion ratio. This is saying 3 grams is equal to 1 centimeter cubed. And what you also need to realize is that 1 cubic centimeter is equal to 1 milliliter. And you should also know, if you didn't look that up, there are 1,000 milliliters in 1 liter. So these here are the conversion ratios you need to know. This one was kind of tricky to pick out just because it gave it to you as a rate. But then again, if you think about it, all your conversion ratios have been rates of some sense. Like, we would always draw them as a fraction. Like this one here would be written as 1 centimeter cubed over 1 milliliter. You would just write it as a rate. Anyways, so with that knowledge, we start with what is given in our first fraction. We are given 2.00, because it likes to use sig figs on this one, kilograms. And we don't have units for the denominator. Your next conversion ratio, if you recall, you set up. So our units are going to cancel. So kilograms are going to go on the bottom and cancel it out. Do we have a relationship with kilograms? We do not. We actually need to write that one. I did not write it. I forgot we needed kilograms. This is... again, if you don't know it, you'll look it up. But I will tell you 1,000 grams equals 1 kilogram. Metric system's pretty easy to memorize. So 1,000 kilograms in 1 gram. So we have, or I'm sorry, 1,000 grams in 1 kilogram. So 1 goes with kilogram, and 1,000 will go with grams. We then have grams canceling. Or kilograms canceling, sorry, then the denominator is going to be grams here. What can grams cancel to? Right here, boom. Centimeters cubed, or cubic centimeters, and we know, given in our problem, the density of sand, 3 grams per 1 cubic centimeter. We'll put the 2 zeros because of sig figs, but we'll just use it. G's will cancel. We now have centimeters cubed. That needs to cancel over here, and we got this guy down here. 1 centimeter cubed is 1 milliliter. You will note that the difference between centimeter cubed and milliliters, we use this for fluids and this for solids. So that's really the difference between them. They are both measuring the same amount, and they are both measuring the same thing, quantity. It's just that we use cubic centimeters for solid things, so this would be the volume of like a cube, right? And then this would be the volume of like a liquid or a gas, some kind of fluid. So that is the difference between those. But mathematically speaking, you'll see how 1 centimeter cubed is the same as 1 milliliter. You really didn't even need this. You could have just went through and been like, well, then this equals a milliliter, and done it that way. But we'll take it the long way. Yeah, I want that gone. So we are now canceling out cubic centimeters, and we're left with milliliters. Let's cancel out milliliters. And that would be this one. I know there are 1,000 milliliters in 1 liter. And then milliliters will cancel out. And you'll note that your answer, your units on the bottom here all canceled, so you don't have anything on the bottom there. And your units on top all canceled but liters, so we're left in liters. And it is asking you 4 liters, how many liters right there? That is our question. So it is asking for liters, so we're all set up. Unit-wise, everything's checking out. Things are canceling. Conversion ratios are all in place. So we just multiply our numerators, which is 2 times 1,000, which will give you 2,000. And you have 3 times 1,000, which will give you 3,000. So your answer is going to be 2/3 if you want to reduce that. Right. Reduce down to 2/3 liters, or if you want to do it, because it did give you kind of like the decimal points, do sig figs with it, this would be 0.67 liters. Because it would be rounded to the 2 decimal points, that's what I'm saying. Or you can be more exact and just say 0.6 repeating liters. It doesn't matter. Any questions on how to do it? Hopefully that fit with your answer. Probably the hardest part for you is figuring out and actually finding these. These are given stuff. You do not need to memorize them. It's something you look up. You are more than welcome to use that little piece of paper or that PDF file that I gave you for conversion ratios on your test, or your quiz, sorry, it is open now. But you do have a quiz tomorrow on dimensional analysis. I'm going to go ahead and unlock that now. And if you have any questions, you can either email me, but technically tomorrow's assignment is to do the quiz. So you have today, tomorrow, get that done. And it is only 6 questions. So if you got nothing for me, I got nothing more for you today except for, study and get your quiz done by the end of the week, preferably. I guess we can talk science real quick here. Actually, we'll hide this. Science. Chapter 7. I didn't get the videos. You're reading it. Sorry. Section assessments. Key terms. And a project. Your project is going to be about sig figs or significant figures. Did we not do a lesson on that? You don't have to worry about sig figs. It's more of a science thing. Well, it's an accuracy versus precision thing, but we will go over sig figs again next year and again the year after that, and you'll do them in high school as well. So don't worry about them today. You can round it however you want. I can tell if you're rounding. It's not the biggest deal. Or you can leave things as fractions as well. Your project, you are to choose a celestial object in our solar system. Please do not pick the sun. Not the sun. Can't do the sun. Pick something besides the sun. This could be a planet. You have 8 planets to choose from. This could be a dwarf planet. You got like 3 dwarf planets to choose from. This could be a comet that enters our atmosphere and then leaves, or not our atmosphere, our solar system, and then leaves. This could also be done on moons of a planet. Right? Moons that are acceptable are, your common moons. Some moons you're just not going to have information on. Like Saturn has like 1 million moons. Well, not 1 million, but it has hundreds of moons. Most of them we don't really care about. They're just like loose asteroids and particles caught in its orbit. But it does have, what is it? Titan. Titan's a very interesting object. So if you want to choose like Titan or something. Titan is on Saturn's moon. You got Triton, which is different than Titan, which is Uranus's moon. Jupiter has Io, Callisto, Ganymede, however you spell that. And Europa. Europa is extremely interesting, and Io is like my favorite. Europa. I mean, those are all possibilities. Mars has Phobos and Deimos. Those are pretty interesting too. Or you could pick our moon. We did a lot on our moon as well. That would work. I just want you to stay away from the sun. You're going to do this in a PowerPoint, so make a PowerPoint of it, or a slideshow, sorry. Put in a slideshow. I like pictures in slideshows. Put lots of pictures. Try to keep about 4 bullets per slide. If you have more, make it 2 slides. Yeah, your choice is what object you want to do. That's where you're getting your choice. But this is your only option. I mean, I guess if you wanted to do a website instead of a slideshow, go right ahead. But pick one, resource it. Also, cite sources. Don't forget to cite sources. You should have a minimum of 3. And your book does count. So if you want to use something from your book. Any other questions about anything? Why not the sun? Because I pretty much outlined the sun already for you. I gave you the outline of the sun. You can probably do a better job than me, but I kind of just threw it together quickly. You can dress it up more. I mean, the information's good that I gave you. Just dress it up more, make it look more presenting than what I did with mine. All right, if you have any questions, I'm available through email. Can we do another planet if we want? Yeah, you can pick a planet. Don't pick one outside our solar system, though. Yes, you can use a calculator on the test. Make sure it's in our solar system. So don't pick one of those strange planets all the way off that we pretty much just have a picture of and we know what composition of through spectroscopy. But yeah, planets are here. And then you can choose your dwarf planets too. I forget what all your dwarf planets are. It's not in our solar system. So don't pick something outside our solar system. If you're not sure, let me know what it is and I'll tell you if it's outside our solar system or not. It looks like a potato to you. Io is like the most volcanically active place in our solar system. It's like covered in volcanoes and lava. It's an interesting one. All of Jupiter's moons. These here are your Galilean moons. When your book said, hey, Galileo observed 4 different moons from Jupiter, noticing that, hey, things actually travel around Jupiter, and therefore that not every object in our solar system travels around the Earth. That was kind of like groundbreaking at the time. But Io is pretty cool. Callisto, Ganymede, Europa is probably the one. Like, if there's life in our solar system outside Earth, Europa is probably where it's at, which makes Europa really interesting. Oh. But I think these are the most interesting things in our solar system, I think, are the Galilean moons of Jupiter. But people can disagree. Titan is also pretty cool. I would suggest Titan. I mean, the planets are good too. It's just that you probably know a lot about the planets already. So I'd pick something where, you know, hey, you can actually do some research and explore something, learn something new. All right, with that, if you have any more questions, send me an email. I'm going to end it. I will not be streaming tomorrow. You are doing your quiz tomorrow for math. It's unlocked now. I just unlocked it. So you can actually get that done today if you really wanted to. But I'm calling it. We're out of here. Goodbye.